So now we have it generating the response in real time, right? We don't have to wait for it to see it. We can just see it as is in real time, which I think is dope. Okay, so first things first, I actually wanted to mess up my environment here for this basic LLM just so that we could start fresh. First off, you're going to want to download the model from Hugging Face. So in this case, we're using Qwen, and I am using the, which one is this? Q4KM. This is the one that we're using right here. I have it downloaded right there, but just in case, you know, obviously you just click there and then click download from Hugging Face, and it'll start downloading. And once it's done downloading, obviously you can then move it to whatever location you want. The next thing that we're going to have to do is we're going to want to make that folder that we just deleted. Let's do that. CD into our home just to make sure. Then we're going to make a directory for everything to be housed in. We're just going to mk-dir make directory, and we will call this the same thing as before, basic LLM. And just do it like that, right? And you can see right there, basic LLM just popped up, right? And so we're going to actually want to go into this now. So we're going to cd into our basic LLM, right? First things first, we can move our Qwen model into there just so that we have it locally. I believe in my script I have it pointing to a different folder, but we're just showing how to do this first. So now that we've made our basic LLM folder, we're then going to create an environment using the Python that we have locally. You should just be able to do this with any, just with the base installation of Linux. But you should be able to go Python 3-m venv venv. Right? We're making an environment. It's just what that says. Right? And after it is done making the environment, we are going to want to activate the environment. So to activate the environment, usually you're going to go into your environment in your bin, and then the activate file is right here. In our case, we don't have to cd all the way down. We're just going to call it from here, right? So we're going to go source env/bin/activate. And now our environment is activated. For this particular project, all we were really doing was using Llama.cpp. So this is for installing it using your CPU. In order to get it to run on GPU requires a tiny bit more, just because on the 5080 series, you do need to install and link. You need to install and link CUDA a specific way, and also turn off secure boot so that you can have both of your monitors working. But for now, we're just doing CPU. Let's install Llama.cpp. So we go pip install Llama.cpp Python. Right? So we've successfully collected and installed all of those into our environment. Yeah, so as you can see here, you got NumPy, Llama.cpp, and all that. I'm going to drag my basic LLM configuration into here. Now, and let's see if it runs. Yep. And there you go. That's how you would set it up if you, yeah, and that's just like the basic setup. So next we're going to go over some of this. So I just wanted to show a really basic setup just because it's kind of difficult to walk through some of this without like breaking it down into steps. In this case, all we're doing is just loading a model locally. So we're going to load the model, and as you can see, it's mounting using Llama.cpp, which we've installed locally. If you want to go through Llama.cpp, you can. Really what we have going on here is we're just telling the script, this is where our model is located, right? Our context size, the amount of threads that we're using, the maximum tokens that it's returning back, right? And that the debug is equal to true. So that's why you're able to see all of this, right? We don't really have to have these configurations here, right? We could separate it to a different file. Well, that's why we have this configuration file right here. We're going to just remove this. And then since we already have a config file that we've made, which has the definitions, we're going to just do from config import. We're importing all these three things. Copy pasta. So now we're calling it from our config file, and we don't need all that gobbledygook at the start. Now the next step is to then being able to respond to it or being able to say something to it, right? So what we're going to want to do is then we're going to have another main somewhere down here, right? And we're going to we're going to redefine this as load model. And at the end, we're going to return our LLM, right? So now we can pass that into another function. So we're going to want to pass the model being loaded, the LLM, into another function, right? So now in our main function, we can go LLM equals model loaded. So there we have our model loaded successfully. And over here, we can just do another print statement. So print local CPU LLM ready. We have our print statement here down at the bottom, and we don't need this. We're going to want this to continue to load. So let's write a loop. So while our main function is true, user input is equal to input, and you're going to say you. And it doesn't really do anything because all we're doing is giving ourselves somewhere to type, right? So the model is true. So since the model loading is equal to true, we're able to type. All right, pretty simple concept right there. We can also set up an exit command. So instead of having to just crash the whole thing by doing Control-C, we're going to just do an if user input lower exit or quit. So if they type that, we're going to break. So now if we type exit or quit, we are breaking from our main loop. So next we're going to want to set up a generate function. That way when we have our user input, we can send it to the model and then have a response back, right? Because as of right now, we're just typing something and it's just a user input and it's not going anywhere. So we're going to define our generate, right? So we're going to be using some parameters of the LLM, obviously, and the user input. So LLM, right, which is our model that's been loaded, and the user input. So anything that we type right now. So we're going to want to define our prompt. We're going to style this a little bit and go user. As of right now, nothing's still happening. We just have our prompt being defined as our user input, and then the next line is going to be like assistant. So what it should see is something kind of like user, and then my typing blah, 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 and then it'll go to the next line and assistant. Right? So now we're going to want to set up sending the prompt now to, I forgot to record, but what we're doing is, you can just think of this as the settings for the response, right? So the response needs to be equal to the LLM, which is going into whatever model you have it pointing to, right? Our prompt is going to be our prompt from above. We're then setting our maximum tokens to what our maximum tokens are in our configuration file. Streaming is set to false for now, and it stops if user is typed in the response. Start off by setting our stream to false, and in this version, as you can see, we are going to start this back up and go hi, and as you can see, the print ends up adding the assistant because it's not actually sending anything and it's just returning assistant. Yeah. Anyways, we want to send all the information to the model. So to do that, we are going to generate, and we're going to have the generate take in the parameters of LLM and user input. So now, if we do this, we go hi. And as you can see, it's now processing information, right? So now that we know that our model is receiving, or at least doing something in the background, we're going to want to print that something, right? So we can go response, choices, and then the index of 0, right? And then we're going to print that response. All right. So now, as you can see, we have now returned our response. So we said hi, and it responded back with, hello, how can I help you today? Obviously, it's in between a lot of this text. What we're going to do is we're going to just get the text. Full text is equal to the response, but we're just going to want the text section, and we will print our full text and return the full text. Right? Oops. We'll go hi, and there you go. We now have our full text. So now we don't even need this anymore, right? We don't need this anymore, and we can have that running through just there. We're going to just return that. And we should get the same response. See? So we got our second response. So we end up adding a empty, we're going to want to change this. We're going to want to change this to stream. And our response is now going to be an empty index, which we're going to iterate. So we're just going to go like over our response. That way we don't have to wait for the entire thing to generate. We can just pick it up as it's generating, right? So we're going to go for chunk in stream. Our token is equal to chunk, and we will put, we're going to do that, right? So for every chunk that is inside our stream, right, we're going to be printing the token. So for each one of those, we're then going to be appending our index, right? We're going to be adding each chunk into it. So we're going to do response dot append and token. Jesus. And we're going to want to return that joint response, right? So it shouldn't be in our for loop though. Right, so now it's just going. Now it's just responding the way it should be. We can do something like this. Yeah. So now we have it generating the response in real time, right? We don't have to wait for it to see it. We can just see it as is in real time, which I think is dope. Obviously, yeah, a little bit of data quarrying going into this as we, and we are optimizing a little bit for our space. We're optimizing a little bit for our time. That way we don't have to wait for a really long response, as opposed to just being able to see it while it's generating. So, yeah. Oh, for example, though, like my model path, right? We could change this. Obviously, this is going into a different folder, but, right? So we could even toss this in here as well. And if we wanted to change the model to be using Llama specifically, we could go like this. Right. We can go like that, and now we're using Llama, which obviously is much faster just for typing. Qwen is for like images and stuff like that as well. Like it can diagnose images. Llama is strictly just for text. So explain science, so it goes a lot faster. But when we're using Qwen, obviously we can use Qwen for multiple different reasons, not just for language, text. So, yeah. The purpose for something like this is that if you have an LLM that's generating text, and let's say you wanted to turn that text into speech, instead of having to wait for the entire text to be output all at once, you could have it streaming it, right? Then you can have other processes using that information while it's streaming it, right? Another thing is that it's not as intensive, right? Because we're not processing the data all at once and then giving an output, as opposed to like streaming it out. So we're thinking about our time, our space time, right? We want to be thinking about how we're grabbing the information. Obviously, you can then utilize it for different types of processing. For example, I actually have like an asynchronous text to speech, right? And then text to speech into deep faking.
Well, hello there. It's nice to meet you. I'm Ariana Grande. I hope this conversation goes as smooth as one of my concerts. Oh wait, are we talking about a specific event or moment in time?
As you can see,
like maybe the time.
There it's processing each sentence at a time instead of the entire thing all at once. Because if it processes the entire thing all at once, then it just takes infinitely longer. Like, for example, if you are talking to a character that has an LLM, if you want to interrupt them, let's say, you don't need to process the rest of whatever text that it generated, right? So instead of having it process everything, you can just cut it off right there. But also, if I'm speaking to you in real time, you want it responding back as quickly as possible. You don't want like a small delay of like 5 or 10 seconds. You want it like pretty quickly. And in order to have that happen, you can't generate the whole text and then generate all the text to speech and then generate all audio. Yeah, just thinking about how to utilize streaming the information, optimizing for space-time. You know, like your big O and all that. Anyways, peace.